Good morning. Let us discuss a few problems from practical maximum and minimum problems. Question number 1. Let's do the second question here. A piece of wire of length 40 cm is bent to form a sector of a circle with radius r centimeter and sector angle theta radian as shown in the diagram. This is the diagram. The total area enclosed by the shape is a centimeter square. Express theta in terms of r and show that a is equal to 20r minus r square. Question C is find the value of r for which there is stationary value of a. And question D is determine the magnitude and nature of the stationary value. As per the question, the length of the wire is 40 centimeter. A wire of length 40 centimeter is bent to form a sector of a circle with radius r centimeter and sector angle theta radian. So a wire of length 40 centimeter. So we have a wire of length 40 centimeter. It is bent and formed a sector. Okay. So this is the main concept which is given in the question. So in every practical maximum and minimum problems or the problems related to rate of change, there will be a situation provided. Okay. In that situation, a particular condition also will be given. So based on that condition, we have to go to the next level of the problem. Okay. Here, length of the wire is 40 centimeter. So when you look at this sector, length of the wire is same as perimeter of sector, isn't it? With the help of the wire, we made this total length. So length of the wire is same as perimeter of the sector, which is 40 centimeter. So this is the given condition. Based on this, we have to check the first question. Our first question is express theta in terms of r. So we have to make a definition for theta in terms of r for this question. Okay, means we have to make an equation for theta. For that, we have to use this given condition. So every question you find a situation and a particular condition according to the situation. So with the help of that given condition, we have to find out an expression like this. Okay, so given that perimeter of sector is 40 centimeter, and we know that perimeter of a sector is 2r plus l, that is r plus length of the arc, which is equal to 40. That implies 2r plus, we know the formula for length of an arc. What is length of an arc? Is r theta. As we are continuing with radian, length of an arc is r theta. If it is degrees, theta by 360 multiplied by 2 pi r, isn't it? So here we use r theta. That's enough for us. Okay, so length is r theta. That's equal to 40. Now it's very simple. Your task is theta as the subject to the formula. So we get r theta is equal to 40 minus 2r, or theta is equal to 40 minus 2r all divided by r as answer for the first question. So theta is 40 minus 2r by r. Part B of the question is show that area is equal to 20r minus r square. We have to show that area of the sector. Area of the sector is 20r minus r square. So let's go to the definition directly. What is the area of sector? Formula for area of sector is half r squared theta, which is equal to half r squared. What is the value of theta? We got already theta as 40 minus 2r by r in the first question. So apply that here. We get 40 minus 2r by r. So now what you need to do is simplification. Just 1r and 1r get cancelled. And we can take, as there is a half, 1 2 you can take outside as common. So this is an even number, this is also an even number. So take a 2 outside as common, we get remaining 20 minus r. Is half and 2 cancelled. We have get r of 20 minus r. When you open the bracket, we get 20r minus r square as answer. Hence shown. Question C. Find the value of r for which there is a stationary value of a. So question C consists of differentiation. Okay. Question A and B was just our basic mathematics which we learned in our previous classes. But question C is from the part of differentiation. So here we have to find the value of r in which there is a stationary value of a. It's a stationary value of a. So we have to make use of stationary value. Okay. As there is a stationary point for a, we get dA by dr is equal to 0. At stationary point, dA by dr is 0. So it implies find dA by dr. When you find dA by dr, because it is a with respect to r, so dA by dr we get 20 of 1 minus 2r, which is equal to 0. Because dA by dr is equal to 0. It implies 20 minus 2r is equal to 0, or minus 2r is equal to minus 20, or r is equal to 10. So we get the value of r. So next question is determine the magnitude and the nature of stationary value. So as per the previous question, we got r is equal to 10 when the area is 20r minus r squared. Now we have to find the magnitude of this value. That means we have to find the magnitude of a. What do you mean by magnitude? The value, quantity. We get a is 20 of 10 minus 10 squared, which is equal to 200 minus 100, that is 100. That is the magnitude of a, magnitude of the stationary value, magnitude at the point of stationary value. Now we need the nature of stationary value. Okay, so remember how to find the nature of stationary value, whether it is maximum or minimum. For that, let us take dA by dr and the value of r as 10. What is dA by dr? It is 20 minus 2r, isn't it? And r is 10. Now to find the nature of stationary value, let's take r is equal to 10. This is the stationary point. Okay, now consider a point which is left of 10, below 10, and 1 above 10. Any value below 10, I'm taking 0. Any value we can take. And above 10, let me take something 20. Let it be. Okay, now we have to think like, if r is 0, what happens to dA by dr? This is a rough work. If r is 0, this portion becomes 0. We get 20, which is a positive value. When r is 10, these are the values of r. When r is 10, dA by dr is 0. When r is 20, in this case, when r is 20, we get dA by dr as 20 minus 2 into 20, 40. That is minus 20, which is a negative value. So here we get the left side of stationary value is positive. Positive means increasing. Means gradient is positive. This is meant by gradient is positive. Gradient is 0 because dA by dr is positive. You know, as per our definition, dA by dr is the gradient at the certain value of r. So dA by dr is positive, means gradient is positive. gradient is 0 and gradient is negative. Okay, so our graph will be formed like this. That means this is the point which will be a maximum point. Okay, so we can say the point, stationary point, that is 10, 100, because stationary point is RA, is maximum. Normally stationary point is XY. Instead of X we have R, and instead of Y we have A, because equation is A is equal to 20R minus R square. It looks like Y is equal to AX plus B. So our stationary point is XY. Instead of that, here it is RA. So the stationary point 10, 100 is maximum. The diagram shows a rectangle ABCD where AB is 20 cm and BC is 16 cm. PQRS is a quadrilateral where PB is equal to AS, that is equal to 2x cm, and BQ is x cm and DR is 4x cm. Express the area of PQRS in terms of x. Given that x can vary, find the value of x for which the area of PQRS is a minimum and find the magnitude of this minimum area. Just read this question carefully. Next question. So, as per the question, ABCD is a rectangle. ABCD is a rectangle where AB is 20 centimeter and BC is 16 centimeter. Then PQRS is a quadrilateral where PB is equal to AS. Where is PB? PB is equal to AS as per the question. Okay, as AS is 2x, PB is also 2x. Okay, so PB is equal to AS, that's equal to 2x centimeter. Then BQ is equal to x centimeter. BQ is x centimeter, which is BQ is x centimeter. And DR is 4x centimeter. 4x centimeter. DR is 4x centimeter. Express the area of PQRS in terms of x. So question A is express the area of PQRS in terms of x. Okay, so we want the area of PQRS. So that means area of this shaded region, and you can find the shaded region is a quadrilateral. Now directly it is difficult for us to find the area. So what we are going to do is, from this rectangle, from rectangle ABCD, what we are going to do is, I'm going to delete this triangle PQ. So from total rectangle, delete triangle PQ. Now delete the next triangle QR. Delete the third triangle SR or RS, the triangle. Okay. And delete the fourth triangle. So we get this shape now. That means area of quadrilateral PQRS is area of rectangle ABCD. From ABCD we have to delete area of triangle PBQ and QCR, then SRD and area of triangle APS. Okay, So now we have to find those areas separately. For that, let's see the values. You see here, AB is 20 and PB is 2x. Total AB is 20 and PB is 2x. So what will be AP? Total is 20 and this is 2x. So this will be 20 minus 2x. Yes. Here, similarly here, DC is 20 because AB is equal to DC. DC is 20 and this is 4x. So this will be 20 minus 4x. Similarly here, this total is 16. This is x. So this is 16 minus x. And here, total is 16. As it is 16, this is also 16. And it is 2x. So this length is 16 minus 2x. Okay. Now let's find the area of each figure. Area of triangle, area of rectangle ABCD is length into breadth, that is 20 into 16. (320 centimeters square). Now find the area of, so this is over. Now we have to find the area of triangle PQB. PQB or PBQ. PQB. Area of a triangle is half into base into height because each of this triangle is right triangle. So we can use half into base into height. It is half into 2x into x. We get it as x squared. Now next area. Area of triangle. What is that? QCR. It is half into base into height. 20 minus 4x into 16 minus x. Okay. In this both you can find a 2 is common because this is an even number, this is also an even number. So if you take the 2 outside, we get 10 minus 2x of 16 minus x. So that we get it as 10 minus 2x into 16 minus x. Let's go for the next triangle. Area of triangle SRT. That's also half into base into height. Half into 4x into 16 minus 2x. We get it as 2x of 16 minus 2x. We'll simplify all these values later, but before that let's find all the answers. And the last one is area of triangle APS. It is a half into 2x into 20 minus 2x. X and x get cancelled. So we get remaining as x into 20 minus 2x. So we got all the required areas. Okay, so now let's find this answer. So now let us replace. Area of triangle ABCD is 320 minus area of triangle PQB. What is area of triangle PQB? Area of triangle PQB is x squared minus area of triangle QCR. Triangle QCR is 10 minus 2x into 16 minus x. Minus area of triangle SRD is 2x into 16 minus 2x minus this one is x into 20 minus 2x. Let's do that. Everywhere we can find a minus. Let's take outside. So remaining we get x square plus multiply, open this bracket, we get 160 minus 10x minus 32x plus 2x squared plus 32x minus 4x squared plus 20x minus 2x squared, that's equal to 320 minus, now like terms, x square minus 4x square plus 2x square. So 2x square minus 2x square get cancelled here. Remaining we have x square minus 4x square, that is minus 3x square. Now x term minus 10x minus 32x plus 32x, minus 32x plus 32x get cancelled. Remaining we have 20x minus 10x as 10x, and 160, only 160 is there, yes, plus 160. So we get, when you simplify, we get it as 3x squared minus 10x plus 160. That is the area of PQRS. Question B is, given that x can vary, find the value of x for which the area of PQRS is a minimum and find the magnitude of this minimum area. Okay, that what they have given is area of PQRS is minimum and also find the magnitude of minimum area. And as per the question, the area is minimum, that means dA by dx less than 0. It implies we have to find out dA by dx. We get it as 6x minus 10 less than 0, or 6x less than 10. It implies x less than 10 by 6. Then we get the critical value of x as 10 by 6, which is 5 by 3, means 2 by 3 as the critical value of x. So that the magnitude of A will be 3 of 10 by 6. 10 by 6 is same as 5 by 3. 5 by 3 the whole square minus 10 of 5 by 3 plus 160. Just do this calculation. We get the answer as 151 2 by 3 centimeter square. Okay.